This is Joseph Abel for individual assignment 2. For the part 1, we are in Xfoil, and I can bring that up. As we can see, Xfoil has already been loaded up, and to begin, we want to do NACA 00, or yeah, NACA 10. Everything here is right. For the next step, we want to go to Operation Viscous. For our Reynolds number, we want to do 375,000, which is correct. Here you can do PACC, which will save everything into a file that you can retrieve your data from. If we do iterations, just in case it messes up or it needs more iterations to converge, we can do 100 iterations instead of the iteration limit before, which was 10. Here, then we can do a sequence from -5 degrees to 20 degrees with an increment of 1 degree. And as it runs, this is giving us our data for all the points from -5 to 20. It's taking a while. And it's done. So if we were to have saved our data, we could open it up into a Word document and then transfer all those columns into an Excel file. As an example Excel file, I can bring one up. So here again, we have all of our data. This is for the current airfoil that we're using from Xfoil. So we have all of our alpha from -5 to 20. And here you have our coefficients of lift, our coefficients of drag, and then our CL over CD. This one you have to manually input by doing CL just over CL over CD. And then we can get our graphs from these. You repeat the same process for the NACA 4410 and then the Epler E385 airfoils. I believe you don't have any issues with running the NACA 4410 airfoil, but you do have issues running it with the Epler, which you just have to change the different convergences or the amount of iterations and to get the numbers that you are missing, you essentially just have to go back to your sequence and change where you start from and where you end from, and then decrease the how much you want to change your angle by to get the numbers that you may not have gotten from the first initial run. And I believe that's it for part 1. We'll do part 2 here in a second.